Hey everyone, welcome back to the channel, and today let's solve the LeetCode problem for the daily challenge. So this is the longest arithmetic subsequence of given difference. So we're given an integer array and an integer difference, and we need to return the length of the longest subsequence in array, which is an arithmetic subsequence, such that the difference between the adjacent elements in it is equal to difference. And we know that a subsequence is the one which you can obtain from a sequence by removing some or none of those elements. So let's have a look at an example. So we're given this array and the difference is 1. So we can take the entire array as the subsequence, because from 1, if we add 1, then we go to 2, then we go to 3, we go to 4. So it is basically able to get an integer array with the difference of 1. Okay, or you can go it backwards. Okay, so 4 minus 1 is 3, minus 1 is 2, minus 1 is 1. So the entire array is a subsequence, and we can just return the length of that, which is 4 in this case. Coming on to the other example, we have 1, 3, 5, and 7. Now in this case the difference is 1, but as we can see, for 1, the next one we need to suffice this is either 2 or 0, but we don't have any of them. Similarly for 3, we don't have plus 1 minus 1, plus 1 minus 1, plus 1 minus 1. So we're going to return the element itself. So that's the answer. And coming on to this one, we can see that the longest arithmetic subsequence is 7, and the difference is minus 2. So 7 minus 2 is 5, 5 minus 2 is 3, 3 minus 2 is 1. So we have this sequence with a length of 4. Now coming on to the constraint, so I would highly recommend you to ask for the constraint if they're not given in a coding interview, because that would give you some idea of the complexity which you need to bring your solution up to. So in this case we see that it's 10 to the power 5. So a kind of a linear or worst case n log n solution is the one which is required. You cannot go beyond that. You cannot be n square or something of that sort. Yeah, that's the limit. And then for the difference, it can be negative and positive. So that's also something we need to take in case. So right off the bat, we can see that this problem is a dynamic programming one, because there are overlapping subproblems. Okay, so suppose for this case, if we know that the length of the longest arithmetic subsequence for 5 is 3, so it's 5, it's 3, and 1. So we know that, okay, you can get one for 3, okay, if you start at 4. So the moment we're on 7 and we want to know, do we have a subsequence? So we're going to come down to 5, and since we've already calculated that for 5, we know that, okay, that's 3. So that would basically be 7 plus the length of the subsequence beginning at 5, which is 1 plus 3, and that's going to be our answer. So this is definitely a DP problem. And I think we'll also be needing an Hashmap to store the indices, or basically to store the values which you have already calculated. So yeah, that's gonna be a DP and Hashmap problem. So let's head to the drawing board and see this example, and then we're gonna come back and code this out. Alright guys, so let's have a look at this example and try to understand the concept. So we're given an array and we have the difference, and here we have the DP hash map, right? So we'll go over the array elements one by one. So first is 1, and the difference is minus 2. So 1 plus 2 is 3, 1 minus minus 2. Do we have 3? We don't, so we're gonna just put in 1 for 1 in the DP. Coming on to 5. Do we have 5 plus 2, 7? No, we don't. So we're gonna just put in 5 is 1. We have 7 plus 2. No, we don't have 9. So we're gonna put in 7 to 1. And we have 8 plus 2, 10. We don't. So we're gonna put in 8 of 1. Then do we have 5 plus 2, 7? Yeah, we do. So we're gonna just add that value to 1. So 5 plus 2 is 7, and that's 1. So 1 plus the value for this, which is 1. So we have for 5 the value as 2. For 3, 3 plus 2, 5. Do we have 5? Yes, we do. So we're gonna just add that value similarly. So for 3, it's gonna be 2 plus 1, so it will be 3. For 4, okay, so for 4, do we have 4 plus 2, which is 6? We don't. So for 4, we're gonna just put in 1. For 2, do we have 2 plus 2, which is 4? Yes, we do. So we're gonna just put in 1 plus the value for that, so that's gonna be 2. For 1, do we have 1 plus 2, which is 3, somewhere? Yes, we do. And what's the value for that? The value for that is 3. So we're gonna just put in for 1, it's gonna be 1 plus the value which we have over here. So that's gonna be 3 plus 1, and that is 4. And now we're done with our entire array, right? So we're done with this. So now let's go over the DP values, and we're gonna just return the maximum value. So what's the maximum value? 1 1 1 1 2 3 2 and 4, right? So this is the answer, right? So we're gonna just return 4, which is the answer. That's it. So we have the DP, this hash map over here, and we have the array. So let's talk about the time complexity. So if we talk about the space complexity, we're just using O of n for the DP hash map, right? So that's, in the worst case, it's gonna go up to O of n. And about the time complexity, we're going over the integer array once, so that's gonna be O of n, and then we are making calls to the DP where we're finding elements, and the amortized one for that is gonna come somewhere to O of 1, and yeah, we're doing that n times, so it's gonna be O of n plus O of n. So yeah, that basically comes down to O of n time complexity. So we're using O of n space, and we're using O of n for time, and that's the total overall complexity for this problem. Now let's go back and just have a look at the code for this problem, which is going to be very short. So let's just do that and hit the solution for this problem. Alright guys, so let's come back and start coding this problem up. So we're gonna need a DP hash map, and then we're gonna just iterate over all the items in the array, and we're gonna keep the value as 1. So that's the default value. Okay, so for every element, the subsequence will have at least that element, so it's gonna be 1 for all the elements. And then we have if the item minus difference and DP. Okay, so we have this before. Then what we're gonna do is we're just gonna add the value for the value which we have already calculated. So we're just gonna take use of the DP. So this is the main DP code where we are already using some the solution for item minus difference which you have already calculated. So we're just going to add that to the value, and if that is not the case, value is going to return, it's going to remain 1 only, and then we're going to assign this value. So that's it. That's the code for this problem, and then we're going to just return the max of dp dot values. Yeah, so that is how you do this, and let's try to check this out, and let's try to submit it, and it should work. Okay, cool. So yeah, we're able to base 78% of the submissions. Now just make sure that you do dp.values. Don't do dp, because if you do that, then it's gonna return the max of the keys. Remember, we want the value, so it's dp won't work. You have to specifically specify dp.values. That is gonna work. And there's one more thing which we can do. That's a theoretical optimization, but that's not really gonna make a difference practically. But let's suppose we use a variable answer. So we don't want to go over the entire dp to find the maximum value. So we can just use a variable which is going to be answer, and that variable is initialized to 1, and then over here we can just do max of answer and value. So and then we can just return this answer, so that at the end we don't really need to go over all the values in the dp, which is going to save us a linear scan through the entire dp. Let's try this out. And awesome, so we're done with this, and let's now try to submit this. It should work, whether the optimization, and it works. That's great. So yeah, that was it about this problem. Thank you so much for making this so far in this video. In case you're liking on content, please hit the subscribe button, please hit the like button, and you're gonna come up with more such content around LeetCode problems, system design, object-oriented programming. So please subscribe and like to the channel. And if you have any questions or you have any suggestions, you want to suggest some optimizations, please leave them down in the comments below, and I'll see you guys very soon in another video. Until then, have a great day and goodbye.